Let's read this little sentence here below the problems that we just answered. A simplified monomial expression is an equivalent expression in which each variable base appears only once. All coefficients are in the simplest form. There are no powers of powers. What that's saying is all of the powers can be combined, and if they are combined, that is called the simplest form. So now, this is something that was shown yesterday, but maybe you didn't get it, maybe you did. So it says rewrite 3 times x to the 5th power raised to the 4th power and expanded form using 3x to the 5th as a repeated factor. So repeated factor means write this according to how much the power is. So 3x to the 5th is being raised to the 4th power. So that means we're going to write that multiplying 4 times. Use the commutative property and associative properties to write it in its simplest form. So that's using the skill that I've been using up here, which is regular numbers combined together, x's combined together. Maybe we should write that note down. Regular numbers combine. Same base has exponents add together. How many 3's do we have multiplying? We have 3 showing up 4 times. So that would be 3 to the 4th power. Product of powers. So then how many times do we have x showing up? We have x to the 5th, x to the 5th, x to the 5th, x to the 5th. So that's 4 times. So that's x to the 5th plus 5th plus 5 plus 5. It really should, once you have it adding multiple times, you shouldn't call it to the 5th anymore. You just say x power 5, power 5, power 5, power 5, all adding together. And in the end, that makes 3 to the 4th power x to the 20th power. When you add those 5's together, it makes a power of 20. So these two things are equal. 3x to the 5th to the 4th power is equal to 3 to the 4th power x to the 20th power. Is there any faster way to get this answer? It wants you to write a rule for that faster way here. So let's look at these two things. Here's a 4, and here's a 4, and there's actually a 4 inside of this number 20 also. 20 breaks down to be 5 times 4. 5 times 4 makes 20. There's a 4 over here, and there's a 4 over here. There's a 5 here and a 5 here. So if we put all this together, what's really happening whenever you have a parentheses and an exponent outside that parentheses is that number outside is distributing to the powers of each number on the inside. So 3x to the 5th is the same as 3 to the 1st power x to the 5th power. When we take this and we raise it to the 4th power, this 4th power is going to distribute to each of these exponents and multiply them. So that's going to be 1 times 4, and it's going to be 5 times 4. And that's going to make 3 to the 1 times 4, which is 3 to the 4th. And then 5 times 4 makes 20. So when you have a parentheses and an exponent outside of that, what happens is The exponent outside the parentheses will multiply each exponent inside the parentheses. It just straight multiplies it. 1 times 4, 5 times 4. So if we have variables, if we have m times n to the x raised to the y power, we're just going to take this number y and we're going to multiply it to each exponent. So m doesn't have a power, so it's really m to the first power times y times n to the x power times y. And that's going to make m to the y, n to the xy power. This person believes that 2j to the 7th k to the 8th raised to the 5th power is equal to 10j to the 35th power k to the 40th power. How we figure that out is we use that new rule that we just learned. Distribute the 5, and it's going to multiply each exponent. So what's the exponent for 2? 2's exponent is 1, and then we're going to multiply it by 5. J's exponent is 7, and you're going to multiply it by 5. K's exponent is 8, and you're going to multiply that by 5. 2 to the first times 5 is 2 to the 5th. J to the 35th. K to the 40th. Which is not the same as what they wrote. Go ahead and try and answer question F and question G. And that'll be the end of our notes, and I'll tell you which problems to do after that. Pause the video. For question F, whenever we have this to the 7th power, the power distributes to each individual piece. That negative there, that's a -1 times y to the 4th times z to the 4th. Then that exponent is going to multiply each power. So -1 to the 7th power is going to be -1 to the 7th power. Y to the 4 times 7th power is going to be to the 28th, and then z to the 28th. And then now let's figure out this -1. That -1 is -1 times -1 times -1 times -1 times -1. Is that 7 times? 1, 2, 3, 4, 5, 6, 7. Every 2 -1s is going to make a positive. So that's a positive, that's a positive, that's a positive. So that's 1 times 1 times 1. And then this last -1 doesn't have a match, so it's still going to be a -1. So whenever you multiply all of these 1's together, they're going to be equal to -1 y to the 28th z to the 28th power, which is exactly the same as the first statement. The second statement, though, whenever it's raised to the 4th power, whenever you have the 4th power distribute to each of these, let's simplify that. That's -1 to the 4th power, y to the 7 times 4, z to the 7 times 4. So that's -1 times -1 times -1 times -1, 4 times. Those two are going to make a positive. These two are going to make a positive. So that's going to make just 1. So in the end, this is going to make 1 y to the 28th z to the 28th, which is not the same thing, which is what they said. It's not the same thing as negative y to the 28th z to the 28th. So the purpose of this was so that you can see Whenever you have negatives, if the exponent is odd, those negatives will stay negative in the end. After you multiply all of them out, it's going to make a negative number, like on the left. But whenever the exponent is even, this is an even number, whenever that even number distributes to a negative, it's going to make a positive number, and therefore your answer will no longer be negative, but will now be positive. Really though, if you expand it out, you don't have to remember that, but I do have a lot of friends who chose to remember that. In this one, when you distribute the 2, you do not distribute from the outside first. You work your way from the inside and work your way outside. This is part of the order of operations. So this 5 gets distributed first to make 2 to the 5th, x to the 15th. Then you can distribute this 2 on the outside, inside, to make 2 to the 10th, x to the 30th. Which is not the same thing as what Hector wrote. Hector said 2x to the 30th, which is going to make 2 to the 30th, x to the 30th. The reason it doesn't make that is because you do not distribute starting from the outside to the inside. You work your way from the inside outwards. And this will be called a chain problem. You'll learn more about chain type problems in calculus and pre-calculus, but mostly calculus. We're going to skip this part for now because your notes are long enough. I want you to answer question 1, 2, 3, just 1, 2, and 3. Good luck.